So in our last example, we pulled the accordion out to put air into it. Now we're going to press that accordion together to make some music. And so I'm talking about example 11 on page 337, and that is to take an expanded version of our logs and contract them to push that accordion back together to turn it back into one log. Part A, we have log base 3 of x plus 4 times log base 3 of y. All right, so in a grand scheme of things, the first step that we want to take when we're contracting these logs back down to one log is we want to reverse the power rule, or take advantage of the right side of the power rule, whichever way you'd like to think of it. This 4 needs to go back to being a power of y in step number 1 here. So let's go ahead and draw this to the right and say step number 1 is going to be log base 3 of x plus log base 3 of y to the 4th. So we've taken that 4 that was in front of the log and instead put it back to being a power. The next thing we want to do is we say, oh, I see a plus between these logs. So that's the product rule. So we want to turn this back to being a multiplication between the two values of our log here. And so that should take care of it. So it's going to be 1 log base 3, but we're going to have x from our first log times, we could put a dot or a times in here, but let's not because it's 2 letters. And again, if there's nothing between those 2 letters, it's implied as a multiplication. So x times y to the 4th power. And so then we've contracted this log from 2 logs down to a single log. All right, part B, we have 1/2 log of a minus 3 log b. Now notice that this log doesn't have a base identified with it. Again, the base is 10 then. So a couple things happening here. First, we need to reverse power rules on both of our logs. So this half needs to go back to being a power of a, and this 3 needs to go back to being a power of b. So let's take care of that first. And then with a subtraction in the middle, we're going to have to take advantage of the quotient rule to put this back to being 1 log as well. So, but the first thing is we're going to take care of the power rule. So log of a to the 1/2 power minus log of b to the 3 power. All right, so we've taken care of that. Next thing we want to do is we want to say take care of this negative, and so we want to make this into a division, a fraction between these 2 logs. So we're going to have log of our first one, which is a to the 1/2 power, divided by b to the 3rd power. That looks pretty good. The only other thing we might be able to do to this is a lot of folks don't like seeing a to the 1/2 power when that represents the square root of a. So let's go ahead and satisfy those folks here and call this the square root of a in our numerator and then b cubed in our denominator. And let's put a parenthesis around it so that we know that all of this is part of our log value here. And again, we've taken 2 logs and we've reduced it down to 1 log. There's a time for this. When it comes to solving, this is definitely a spot we want to take advantage of these rules, these product and these quotient and these power rules. It's for the solving of logs. Okay, part C, we have the natural log of 5x minus 3 natural log of z. All right, so again, first thing we do, take care of the power rule. So this 3 is going to go back to being a power on the z. Nothing doing with the 5x here, so that's going to go ahead and stay as is. So natural log of 5x minus natural log of z3. All right, so that's the first thing we take care of. The next thing we look at is we look at the subtraction. Once again, it's the quotient rule. And we say, okay, that means we're going to have 1 natural log. Our numerator is going to be from the first natural log, so that's 5x. Our denominator is going to be from the second one, which is z to the 3rd power. And there's no more really that we can do to simplify this other than let's put a parenthesis around it to give it some context to make sure that the 5x divided by z cubed is part of that natural log, but there's no more we can do to this. So again, expanding we did in example 10. Contraction we've done here in example 11. So the product, the quotient, and the power rules, they all go both ways. A lot of people think it's just left to right, but it really goes left to right and right to left. So that's what example 11 is really intended to show you, is that you can go right to left too, and to make them smaller. When it comes to solving, this is going to be key for us.